Okay, we're going to continue on here with factoring practice. We're going to start with the special patterns portion. So the special patterns we learned were when we had a difference of two squares, and that was a squared minus b squared. And anytime we saw something that could be written as a square and something else written as a square with a minus sign, we could then factor this over the complex numbers or the real numbers depending on what we had. And it always factored into where you could write the parentheses, and whatever the square root of this number was would go here and here, and wherever the square root of this number was would go here and here with a plus and a minus sign. So that's what we're going to work on here. So in this case you see one term here and one term here with a minus sign. Okay, this is already written as a square, and 36, you know the square is 6. Okay, so the square root is 6. The square root of this then is x minus 7. So if I set up my two parentheses here and I write this out, the square root of this was x minus 7, because remember, square root and a square just cancel out, so I write x minus 7 in the front of each of these. I'm going to do one plus and one minus, and remember there's a plus and a minus because that gets rid of the middle term, the middle x term. And then the 36 is going to be a 6 and a 6. And in this case, anytime you have two real numbers within the parentheses, you can simplify. So this is going to simplify to x minus 1, and this will simplify to x minus 13. So you've got your answers there. In this case down here, I can look at it, and again, I have two quantities that are written with a minus inside, and I ask myself, do I know the square root of it? So the square root of 49 is 7, the square root of 4x squared is 2x, and so yes, I do, so I can write it as 2x plus 7 and 2x minus 7. Now, just as a reminder to you, if we had 4x squared plus 49, we could also do the same thing. We rewrite this problem as 4x squared minus negative 49. So we have the minus sign. This is our first part, this is our second part, and there's our minus sign. The square root of 4x squared didn't change, so it's 2x. And the square root of negative 49, if you remember our square roots of our negatives, is going to be, if it's a square root of a negative, it's going to be I, and the square root of 49 is 7, and so we put that together and we get 7i. So this is a 7i here. So anytime you see the plus sign, you're going to have an I in your second term. And I would write this then as 2x plus 7i times the quantity 2x minus 7i. And you can see the difference there. So the difference between a minus and a plus is just that the last term is going to have an I on it. If you don't know the square root of whatever it is, just leave it as a square root symbol and write it so it could be something like I square root of 15 in there. Okay, if we look at the next piece here, greatest common factors, find a greatest common factor and factor it out. So if you see where there's a lot of numbers that possibly are divisible by the same thing, or letters, then you try to factor them out. So 17, 34, and 51 are actually all divisible by 17. So we want to divide by 17, and anytime you divide, you have to divide everything by it. And when we divide by 17, we put that outside of the parentheses. We're not factoring right now, so we're still going to end up with the three different terms, and we're going to write them in. These are our leftovers. Okay, I've been referring to them as leftovers, so that's what this is. 17x squared divided by 17. So 17 divided by 17 is 1, and we didn't take away any x squared, so it's a 1x squared. Plus, we didn't change the sign, 34 divided by 17 is 2, and we still have that x left, and plus 51 divided by 17 is 3, and so we have our terms there. Now, anytime you have an x squared left in an answer, you always check to see if you can factor more. So we would write this out, and to get x squared, we would have an x times an x. To get 3, it either has to be 1 times 3 or negative 1 times negative 3. And if I look at this list here, none of those add to 2. So we will not be able to factor, and our final answer is actually what you see right here. We still factored, we did a greatest common factor, so we factored out of 17. This is a factorization of what we started with. Okay, so it's not factorable. If we look at our next one, what do they have in common? So think about this to yourself for a second. You should see that they all have a 13 in common, so we can divide everything by 13. But not only do they have a 13 in common, they also all have an m. And whenever you're looking at it and everything has a variable in common, whatever the lowest exponent is the one that's going to be in common with all of them. So an m to the first here is our lowest exponent. So we're going to divide everything by 13m as our greatest common factor. And if we look at this, 13m divided by 13m, now this is where a lot of people go wrong. It is not 0, it is 1. Plus, you will always end up with the same number of terms as you started with. 26 divided by 13 is 2, m squared divided by m leaves 1m left. Minus 39 divided by 13 is 3. M cubed divided by m is m squared. Again, you could check your factorization, but we're going to stop right here. So there's our greatest common factor in that case. Looking at the next section and the last section here, those imaginary numbers. And I already kind of touched on this, but I want to touch on it again here. So we have two terms with a plus sign. We want two terms with a minus sign. So how do we do that? We rewrite it. X minus 3 squared does not change. I want to change this to a minus sign. So to change it and not change the problem, I can do minus a negative. Remember, minus a negative is plus a positive, okay, or a positive. So it's the same thing. These two equations are equal to each other from here to here. So now here's my first term and here's my second term with the minus sign. The square root of this term is just x minus 3. The square root of this term, so I'm looking at the square root of negative 15, is the square root of negative 1 times the square root of 15, which we know the square root of negative 1 to be I, and we don't know the square root of 15, so we leave it alone. So we have I root 15 as our answer here. Write one with a plus, one with a minus. So x minus 3 plus I root 15 and x minus 3 minus I root 15. You cannot simplify these anymore, so you have to leave them right as is, and that is my final answer. The more basic ones here with the plus sign, again, you're still going to rewrite it with a minus sign. You're going to look at your two terms. You're going to say, what is the square root of x squared? So what times itself is equal to x squared? And that is x. What times itself is equal to negative 81? Now remember, it can't be 9 times 9. It can't be negative 9 times negative 9, because none of those make a negative 81. So that's where the imaginary comes into place. If we do 9i times 9i, we get 81i squared. And remember, this I squared is equal to negative 1. So this is a negative 81. Those are the numbers that I want. So we get 9i here. And so then we rewrite it. X plus 9i and x minus 9i. And this is our final answer here. So based on these videos, you've gotten a little bit of a glimpse into what we are going to do. I want you to flip your sheet over, look at the mixed practice section. You have 18 questions to answer. Notice you're factoring completely over the complex numbers. So if there's more than one step, you need to go through all of the steps that are possible there. And you want to factor all of these. We will look at this worksheet on Wednesday and turn it in then. So good luck with those.